Hello, today we're going to do disk method for AB calculus. So we're just going to jump right in. I tried to lay out some steps. Basically, what disk method is used for is it's used to convert an area under a curve into a volume. So we're going to start off with the first thing. I laid out some simple steps. We're going to start off with this graph right here, which is y equals x squared. So it's a simple parabola. Our curve is going to be bounded by the lines x equals 0, y equals 0, and x equals 2. So we're going to forget about this whole section basically. We're only worried about everything to the right of the y-axis. So we're going to just draw our little line because that's all we're worried about. And then we're going to draw a rectangle. Now, the rectangle is symbolic of the area under the curve, like when we did Riemann sums. But now we're going to be rotating that rectangle, and technically the entire curve, around the x-axis. So it's going to be symbolized by a spinning arrow on either the y-axis or x-axis. So we have a rectangle that we drew that's perpendicular to the x-axis. Now that's important because if it's perpendicular, you're going to use disk method, and if it's parallel, you'll use shell method. So we're going to start off. The first thing to do is just notice what kind of axis of rotation we have, and that's going to dictate what method we're using. So we're going to use disk. We're going to write our integral. So typically, if we were doing this, to find the area under the curve, we do the integral of x squared dx from our lower bound, which is 0, to our upper bound, which is 2. But in this case, we're not just worried about area, we're worried about volume. So when this is doing its revolution around the x-axis, it's going to create like this type of thing, right? But with volume. So it's going to be like a circle. So basically, we're making our integral into a circle area equation. So we're putting a pi, and then the area of a circle is pi r squared. So we're going to take our r, which will be the height of our rectangle, which is going to be x squared. We're going to square it, and then obviously there's a dx. So this is what we're going to be solving for. So we're going to take our calculators right here, and we're going to put second pi, right, second integral, x squared, comma x, comma 0, comma 2. And then we'll get the right answer, which is 32 pi over 5. And that's disk method. We're going to do one more practice problem after this. So let's get started. Okay, so the next curve we're going to be working with is y equals x minus 3 squared. So I went ahead with my graphing calculator. I just graphed it. And if I put F3, I can follow the curve and find that at the point 3, it'll hit the x-axis. So it'll be 3, 0, which means that I can basically go ahead and forget about everything to the right of 3, right? So this is what we're working with. So I didn't know if I explained it well enough, so I'm going to explain it again. What we're going to do is draw our rectangle. Wow, that's whatever. It's a gross rectangle, but that's a rectangle, and this represents the area under the curve in this position. So if we have a rectangle, boom. We have a rectangle like this, and we're rotating it this way. Essentially what it'll do is it'll have like a circular shape that's going to come out of it. So we're using the area formula of a circle and putting that into our integral to yield the volume of this curve bounded by the x-axis when it's rotated about the x-axis. So our integral is going to be pi, our little integrand, and then the height, which is the radius. The height of the rectangle is the radius, so that's this, x minus 3 squared, because that's pi r squared, dx, bounded by 0 and 3. So 0 and 3. And then we're just going to plug it in exactly like that into our calculator. You'd put pi integral x minus 3 squared comma x, comma 0, comma 3, and you should get 243 pi over 5. Okay, so I decided to add this one in because it's a very common type of problem that could be on the opportunity tomorrow or on the AP exam. So this question says, what definite integral represents volume of a sphere with a radius of 2? So the first thing that we're going to do is write the equation of a circle that would have a radius of 2, which would simply be x squared plus y squared equals 4, right? So the next thing that we're going to do is solve for y, so that'd be like y squared equals negative, x squared plus 4, and then y would equal the positive or negative square root of 4 minus x squared. Okay, so the next step is I graphed it. So I just plugged it in, and this is what you get. So let's put that. And it's where this point is negative 2, and this point is 2. And since we'll be rotating it about the x-axis, these are going to be our 2 points. It'll be bounded by the x-axis, sorry. Oops. Okay, so we're going to go ahead and draw our rectangle. Boom. And then what we're going to do is plug it in just like we have with all the other things. So in this example, the height of the rectangle would be this, which is the square root of 4 minus x squared. So it would be pi integrand of from negative 2 to 2 of the square root of 4 minus x squared dx, right? And then the other thing that they could do, that would be the right answer, right? So we would just plug it in, and when you put it into your calculator, I'll show you guys here. When you put it into your calculator, you should get 32 pi over 3. But the other thing that they could do is if you pretended that you were going to split this in half and you were going to pay attention to the other part of this, if you found the volume of this area and you multiplied it by 2, it has symmetry, so it would be the same thing. So the other way they could put it is they could bound it at 0 like this and make it the 2 pi, right? Because it would be just multiplying it by 2 from 2 to 0 of the same thing, which is square root of 4 minus x squared, right? And it would yield the same thing, which would be 32 pi over 3. I don't think I even wrote any of these answers down, but that's it. We're done with disk method. It's really easy. As long as you guys know the process, you'll do great. Yay!